are vectors that are in a particular direction. We join them up tip to tail and we figure out what the resultant vector is. Another calculation that you have to be able to do for higher physics is to resolve a vector. And that basically means putting it into its two perpendicular components. So something that's projected at an angle like this, whether it's force or whether it's velocity, has both a horizontal and a vertical component to either its motion or to its force. We talked about Angry Birds, for example. You know, the Angry Bird will follow a path like so. However, whatever angle you project that at determines how much horizontal velocity it has and how much vertical velocity it has. The same can be applied to force and to all kinds of vectors. So if we start out with a force like this at an angle, we can resolve that into its two constituent parts, its perpendicular components, and this is what is called resolving a vector, or the resolution of a vector. So we've got FH, which means it's horizontal force, and we've got FV, which is this vertical force. If we want to figure out an equation to use for figuring out what horizontal force and vertical force are, we can just use simple trigonometry. So if we take cos theta, that's going to be the adjacent side over the hypotenuse. It's going to be FH divided by F. Rearrange for FH and we get our first equation here, which is FH equals F cos theta. So if we want to figure out what this horizontal component of the force is, we know what F is, we know what the angle is, then this is the equation we use. Apply the same technique to the vertical force this time, and sine theta is opposite over hypotenuse, so it's going to be the FV divided by F. Do the same by making FV the subject of your equation, and you get F sine theta. So if we want to figure out what the vertical component of force or the vertical component of velocity or any vector is, then it's going to be F sine theta or V sine theta. So we then went on to do an example. We used velocity to start off with. We had a golfer who hits a ball at 40 meters per second at an angle of 30 degrees. Figured out that this is the path that it would follow. It would follow that kind of parabolic path, which all projectiles do, but we'll look at that later. What are the initial horizontal and vertical components of its velocity? So as we do in all examples like this, we're doing a little diagram just to help us to figure out what's going on. So we've got 40 meters per second at an angle of 30 degrees. That is a mixture of, or a result of, the two different components of velocity, the perpendicular components. So the horizontal here and then the vertical. If we want to figure out what the horizontal component is, as we discussed just a minute ago, it's going to be U cos 30, and then for vertical it's going to be U sin 30, just from simple trigonometry. So we can see that the horizontal component of the velocity here from the resolution of the vector is 34.6 meters per second, and the vertical is 20 meters per second. So that basically means that there is more velocity in the horizontal direction than there is in the vertical direction. And that would hold with what we predicted would be the case when the golf ball started to move. It's going to go further really in the horizontal direction than it is in the vertical direction. So this is helping you to really analyse, what real motion will do. The second example we looked at was involving force. So instead of looking at velocity, we looked at force at a certain angle. So we had a roller being pulled across a lawn with a force of 20 newtons at an angle of 20 degrees. And we're asked to calculate what the acceleration of the roller is. So what we need to do first of all is figure out what this component of force is here. And that component of force is going to be the horizontal component. So we figure that out first by doing F cos theta. That's the force in this direction. And then we use F equals ma from Newton's second law to figure out what the acceleration is. So that's our unbalanced force in that direction. Then we use acceleration. The final and perhaps most complicated example that we looked at was where we've got more than one horizontal component of force. So we've got an oil rig being pulled along by two tugboats, both of 100,000 newtons. This angle is 90 degrees in here. We cut that angle in half, so we've got 45 degrees. Calculating the acceleration, our horizontal force here is going to be 100,000 cos 45, but it's going to be twice that. It's going to be twice that because we've got two horizontal components of force in the same direction. So we calculated what that was and then figured out A equals F over M from that. So we can resolve vectors for force, for velocity in exactly the same way. They are made up of a horizontal component and a vertical component. And if we want to figure out horizontal, it's going to be F cos theta. And we want to figure out vertical, it's going to be F sin theta. So that just comes from simple trigonometry, and that's as complicated as it gets for resolution of vectors.